Alright, this is going to be part one of a video I'm going to make. So I'm going to make a video following this up, talking about why when you have light that is hitting a parabolic mirror, and the light ray, if it's parallel to the principal axis, which kind of crosses the center and the focus, that light will always reflect to the focus as long as it's parallel to the principal axis. And in the next video, I'm going to talk about why using some math. And part of that math involves taking the derivative of this function of the parabola, and you would have a tangent line with that slope. So this ray would have a slope, this slope is really 0. It would reflect off this line, which has a certain slope equal to the derivative of that point because it's the tangent line. And that resulting slope will hit the focus. I want to show you, this is really just a math video. I'm going to show you how to find the slope of that resultant line, or the reflected line, what its slope would be in terms of the incident slope. So I'll call that M1, and then the mirror slope, M0. I'm going to show you how to get that. This is not a physics video. I'm not going to talk about optics. This is purely just a derivation for the next video. So in the next video, I can be like, hey, if you want to know where this equation comes from, watch this video. Here you go. So to approach this problem, you kind of the best case scenario is if this is flat. Because if this mirror is flat, or not really a mirror, but hopefully you know what I mean. This is a line. I'm treating it like a mirror. If our line is parallel, or not parallel, but flat, I guess, horizontal. There you go. That's the word. Horizontal. Then this is simple. M2 is just going to be the negative of this slope, M1. So that's the best case scenario. And hopefully that makes intuitive sense. If you're not sure why, recall that for the law of reflection, this angle theta is equal to this angle theta. If these angles are the same, that means the tangent of that angle is the same. Well, what's the tangent? If you make a little right triangle, you have y and x. Hey, tan theta is equal to y over x in this case, right? Because this is a right triangle. Y over x is a slope. So if they both have the same theta, tan theta is the same, so they have the same magnitude of slope, the same steepness, but obviously it's going to be reflected. It's a negative. Hopefully that makes sense. So the best way to go about this is actually you have to kind of reorient your axis, kind of like you do with FBDs. You reorient your axis. So when you reorient your axis, let's do it like this. So let's say we reorient. I just erased that when I really didn't need to. But if I reorient my axis, I get all new slopes. I get M0, I'll say prime. I get M1 prime, and I get M2 prime. M0 prime is just equal to 0. So when I reoriented my axis relative to the axis of the mirror line, or the line that's doing the reflecting, it's equal to 0. So all I got to do is now find this in terms of M1 and M0, and then I can find this, because I know this just ends up being negative M1 prime. Hopefully that makes sense. I'm surprised this worked, honestly. I'm really surprised this worked. I checked my answers on Desmos. I did some. This is right. This is right. You can trust me. Let's go about this. So here's how you kind of want to think about this. Let's say you have an axis, like an XY axis, or YX, Y versus X, and let's say I'm going to draw that line with M initial, right? Slope initial, or this slope. This is what I'm drawing. And then you have M1. So I'm not worried about M2, right? Because I know to find M2, I just need to focus on this. It's going to be the opposite. So let's say there's a certain point right here, X, right? So I know this is going to equal X, Y. And then let's say this point would equal X, Y initial, right? For the point on the like initial, mirror line. I'm gonna call this a mirror line for now. That just makes the most sense to me. So if I were to draw this little schematic, right, I'm kind of creating, right? Let's do it like this. So if I have my line like so, I want to draw this as best as possible to make this make sense. So boom, this is M1, this is M2, or not M2, sorry, MO, right? M initial, mirror line slope. And then this is my horizontal. And then if I were to connect these lines, right, I get a right triangle. The sides of this right triangle, I will say this is X, right? Hopefully that makes sense because I am like an X away. So that would be X. And then obviously, the lines will continue. These are lines, but I'm just making a triangle out of them. This side would be Y initial. Hopefully you see Y, because this point is Y initial. And then this side would be Y minus Y initial, because the whole thing is Y, so you take away Y initial, you get this side Y minus Y initial. What you want to realize right now is that M1, if we were to reorient our axis like so, like I did, if you think about like this side and this side right here would be H. I can call it H, right? It's not actually H, but I can draw a line from a point on the M1 to the mirror line and call it H, and then this distance right here would be B. So I know at the end of the day, M1 prime is just going to equal H over B, right? My reoriented slope, I can call that M1 prime equal to H over B, right? Rise over run. So I just need to find H and B in terms of this stuff, and then I can find M1 prime in terms of our slopes. So H over B, I need to find H and B. Well, what I can do is, remember, this is just a reoriented, right? I just tilted this. So if I were to draw H and B on this graph, it would be like right here, right? Because if this is M initial, if I reorient it, this line is just perpendicular to that mirror line. So this height right here is H. Now, and this whole thing is B, that whole like point from here to here, that whole distance. So what I'm going to do is I can call this segment C, and then I can call this segment B minus C. And then finally, I'll just call this big distance D. This is really just a lot of geometry. Cool. Now, what I'm going to do is I'm going to do some math. I want to get H and B in terms of my known like X's and Y's and M's. I don't want it in terms of D's and C's and other stuff. So here's what I can do. I can set up a few right triangles, which I kind of did. I can say that D squared, so D squared, that distance squared, is equal to, first of all, X squared plus Y squared. Hopefully you can see that. X squared plus Y squared. But it also happens to be equal to B squared plus H squared. So that's one kind of thing I can remember is that, hey, these two are equal. So I can set these two equations equal to each other. Now, what are some other right triangles I can set up? I can say, well, C squared is just X squared plus Y initial squared. And I can also say, oh, this is going to get crazy, Y minus Y initial squared is equal to B minus C squared plus H squared. So those are four right triangles I have that I can use my advantage. Let's start here, just because it's kind of the nastiest, and why not? Might as well go into the nasty stuff first. I have to square this binomial, so y squared minus 2y initial plus y initial squared is going to equal b squared minus 2bc plus c squared plus h squared. Okay, couple things. First of all, I have a b squared and an h squared. So what I can do is I can just be like, hey, well, I know b squared plus h squared equals d squared. D squared is equal to x squared plus y squared. So I can replace b squared plus h squared with x squared plus y squared. So I can say y squared. So let's go over here. Let's go over here. So I can say y squared minus 2y initial plus y initial squared is going to equal b squared plus h squared is the same as x squared plus y squared. And then this is also cool. I can say, hey, c squared is just x squared plus y, or x squared plus y initial squared. So plus x squared plus y initial squared. And then I'm left with a minus 2bc. And what that does really quickly is it gets rid of my h's. So I can solve for b in terms of anything else. We have a c, but c is just in terms of x squared plus y squared. So I got rid of h. That's awesome. I have y's on both, y squares on both sides. I have y initial squares on both sides. I can just drop them, just like I do with everyone in my life. I can just drop them. So minus 2y initial is going to equal, I have x squared plus y squared, which is 2x squared, minus 2bc. I can just say minus 2 square root x squared plus y initial squared. Actually, I'll save that for the end. You can see I can make that substitution. I'll save it for the end just for simplicity. Okay. I'm going to skip a few steps because I realize I'm going to run low on space really soon. I'm just going to solve for b. So I can add it here, get back there. I can drop the 2's. That's one thing I can do. I get bc is going to equal x squared plus y initial. That's fun to say, y initial. And then I can just say b is equal to x squared plus y initial over square root x, or not x initial, but x squared plus y initial squared. Hopefully you can see where I got that, right? C squared, just take the square root, substitute that back in. I don't like having like squares, roots, and stuff, so I might as well square root both sides, or square both sides. Also because I know I'm dealing with triangles, so I'm gonna have a b squared eventually, so might as well do it now. I get b squared is equal to, yikes. I'll square this later. X squared plus y initial squared over x squared plus y initial squared. Now we just gotta get h's. Now we just gotta get h in terms of, I gotta get h in terms of this stuff. So, let's do that. Let's use this relation right here. I can say x squared plus y squared. So x squared plus y squared minus b squared equals h squared. Hopefully you can see how I can set them equal to each other. Minus b squared. X squared plus y squared minus b squared. See, told you I'm going to need it. I'm going to square the binomial while I'm here. So it's x to the fourth minus 2x squared y initial plus y squared y initial squared all over, goodness me, x squared plus y initial squared equals h squared. This is going to be a fun derivation. Okay, now I got to do my common denominator stuff, right? If this is just over 1 and over 1, I have to multiply by x squared plus y initial squared. So just to save some time, I'm going to kind of do some of it in my head because there's still more to go after this. But what I'm doing is I'm just multiplying x squared times this. so I can get it like a common denominator, right? So I can have it over like x squared plus y initial squared, x squared plus y. Whatever I do to the bottom, I have to do on the top type of thing. So really what I get is, okay, I'm gonna kneel down. I'm gonna kneel down just because I'm gonna be here a lot. X squared, x squared plus y initial squared plus y squared, x squared plus y initial squared. You're actually gonna see something probably, maybe. Minus, yikes, this is gonna be a lot. Minus, okay, I'm minusing all the numerators. So I'm doing minus x to the fourth plus 2x squared y initial minus y squared. I don't know what my mom just said. All right, minus all that all over, because I did the common denominator, all over x squared plus y initial squared is equal to h squared. Goodness me. But what you're going to hopefully see is we're going to get a lot of canceling out. So, okay, I'm gonna erase this diagram. I know it was helpful. Sorry about that, but I need space. I'm running a little low on space. Let's distribute everything. I get x to the fourth times x plus x squared y initial squared plus x squared y squared. I'm distributing the x to each thing, plus y squared y initial squared minus x to the fourth minus 2x squared y initial minus, so plus the 2x squared minus the y squared y initial squared. Looks good, I think. All over x squared plus y initial squared, goodness me, equals h squared. Okay, hey, this is why I did this, because look, the x to the fourth term cancels out. This y squared y initial squared term cancels out. And I'm left with h squared. Oh, this is cool. H squared is equal to x squared y initial squared plus x squared y squared. Ooh, I messed up, I think. I messed up somewhere. Oh my god, I messed up. Yeah, I did. I multiplied this wrong. This is a plus, so this is a minus. This is a minus. If you caught that mistake, you're probably like really scared right now, because I just made that would have been a real, like, imagine I caught that mistake at the end and I have to trace backwards. That would suck. So 2x squared y initials all over, oh my god, all over square root, not square root, but I'm going to square this square root this in a second, all over x squared plus y initial squared. Oh my god, now I can factor out an x squared. So I say h squared is equal to, I gotta look at the camera once in a while, am I right? H squared is going to equal, factor out an x squared on top, y initial squared plus y squared minus 2y initial. Look at that, x squared plus y initial squared. Look, this y initial squared plus y squared minus 2y initial, that is in the a squared minus 2ab plus ab, or a squared minus 2ab plus b squared form. This is just squaring a binomial. So I can replace this with y minus y initial squared. I'll do that. That's a little bit nicer. Because I know this is supposed to be a general solution, but I know y, whatever. Y minus y initial squared. So h squared is going to equal that. So that's cool, am I right? I really hope there wasn't an easy, I really hope just looking at this is not an easier way to do this. I'm going to square root both sides now. So square root, I get h is equal to x. So I can pull the x squared, I can pull the y minus y initial out. So y minus y initial times 1 over square root x squared plus y initial squared. You might be saying, that's a weird way to write it. Why would you not? You'll see why. Because, hey, I'm doing this still. This was still the day one objective. So m1 prime is equal to, oh my god, it is equal to x, y minus y initial, times 1 over the square root. I'll do this. You know what? Just to make it's not a big deal at this point. X squared plus y initial squared over. Now b is equal to, if you got rid of the little this right here, it's just equal to x squared plus y initial times the same 1 over x squared plus y initial squared. So the reason I did that is so I can just cleanly cancel this out, right? Top and bottom both have it. So I get m1 prime is equal to x, y minus y initial over x squared plus y initial. Now what I can do is I can substitute in my m's. So remember, the equation, I erased it. I wish I didn't, but this was my origin right here. 0, 0. So if I think about this line as a function, I know that y1 is just going to equal, or y is just going to equal m1 times x. And then y initial is just going to equal m initial times x, right? Because it's just a line. It's the equation of a line, and it's passing through the origin, so there's no y-intercept. That's why I chose, like, you could do this derivation anywhere. I'm sure the y-intercepts will cancel out, but you might as well do it at 0, 0. So m1 prime is equal to x y minus y initial. So what am I doing? I'm doing the substitution. So x, y is just m1, m1x minus m initial x over x squared plus m1x times m initial x, right? Because I'm doing y times y initial. I can factor out an x here. I can say x squared times m1 minus m initial over, then I could say, well, this is really x squared plus m1 m initial x squared. And then I can also factor out an x squared, and I get x squared 1 plus m1 m initial. And then, of course, the x squareds cancel out. So what I get, I'm going to erase the mirror, because this is important. What I get is I get this right here. I get m1 prime is equal to m1 minus mo, the difference of the slopes, over 1 plus the product of the slopes. So that's kind of cool. All of that work just for something that simplifies real nicely, honestly. Here's what we're going to do next. We are going to now do the M2 stuff. So I know that M2 prime is really just equal to negative M1 prime. But really quickly, what I can do now is I can kind of say, well, the same thing applies for M2 prime. So I know M2 prime, like what I can do, this is kind of like a law, right? This law tells us that for a line reflecting off another line, the slope of that reflected line will equal line of the incident minus the line, or slope of the incident minus slope of the mirror over 1 plus their product. So I can say, well, M2 prime is going to follow that same law, right? So M2 equals M2 minus M initial over 1 plus M2 MO. But I also know M2 prime is equal to, M2 prime is also equal to negative M1 prime, right? When you have your axis reoriented. So this is really just going to equal negative of that. So the way I can make that negative is just by really quickly flipping M initial minus M1 over 1 plus their products. That's cool. That's something I can do, and I can solve for whatever I need. So I can do this here. I'm running out of space, and I gotta write a little bit carefully. But now it's just a matter of solving for M2. So, okay, M2 minus M initial over 1 plus M2 M initial is gonna equal the other. So M initial minus M1 over 1 plus the product of the slopes. Now, oh man, I'm gonna have to do cross multiplication. So M2 minus MO 1 plus M1 MO is gonna equal 1 plus M2 MO. Oh my gosh. What am I doing? Okay. I was just thinking in my head. I'm so sorry for the silence. Okay, 1 plus MO minus M1. Okay, I just got my hands over my beautiful diagram. It's fine. Binomial multiplication. So M2. You could do your FOIL. You could do whatever. I'm gonna do it my way. M2 M1 MO minus M1 MO minus M1 MO squared is gonna equal it's gonna equal MO. MO plus M2 MO squared plus M2 MO squared plus MO. Wait, I messed up somewhere. Oh no, I didn't. I'm good. I'm good. MO, right? And then minus M1. Now I get all my M2s on one side. I'm gonna factor M2 plus M2 M1 MO, and then minus M2 MO squared is going to equal everything else that I moved on to the other side. So plus MO plus M1 MO squared. So I guess plus 2 MO because we have 2 MO, or ooh, we have 3. How do we get 3? How did we get 3? How did I get 3? I have my, wait, let me look at mine. This side. I got 3 somehow. And this is right. I'm so confident it's right. It's crazy. I got 3 somehow. So on this side, yeah, I got 3 by mistake. So I think I did boom. Yeah, and then, yeah, okay, this is where I did a mistake. So I got, there would be another M2. So I get MO plus, so I get MO. Okay, this is crazy. Okay. Oh my god. Well, I just want to check how much time we're at because I know we're almost there. 29 minutes. Okay. So I have MO. I have M2 MO squared. No, MO, and then I have M minus M1. There we go. This makes way more sense. Plus m2mo squared minus m2m1 mo. Oh my god. That is nuts. Why would they make us do that? Okay. I'm looking at my notes just to make sure I'm doing this right. I think I am, though. Yeah, I think I am. Because then, so because of my mistakes, there would be two. Oh my god, I don't want to do this anymore, but I have to. It's for the people. The 5 people that have probably made it this far. Comment Cookie if you've gotten here so far. I'm just curious if anyone has. So 2 m2m1mo minus m2mo squared. That looks about right. And then I have on this side m1. I have mo minus m1, 2mo because there's 2. Yeah, because there's this 2mo minus m1 minus mo squared, m1 mo squared. Goodness me. I can factor out the m2, and I'm just going to skip the results, I'm going to skip the factoring because this video is already long enough. You get 2mo minus m1 minus m1 mo squared over 2m1 mo, sorry, minus mo squared plus 1. That would be the slope of your reflected line. There you go. That's a derivation of all time. It only took 30 minutes, right? This is only a 30-minute derivation that one person's gonna find useful, but it's the equation. That box equation is the equation I'm going to be using in my next video, where I talk more about physics and less about squaring binomials and Pythagorean theorem.